Hello everyone and welcome back to the channel. In this video, we are diving into how subscriber authentication works in 4G mobile systems, a vital mechanism that safeguards every LTE connection. You will learn how the home subscriber server HSS, mobility management entity MME, and user equipment UE work together to establish mutual trust between the network and the subscriber. If you have not yet watched our previous videos on authentication in 2G and 3G mobile systems, I recommend starting there. They offer the groundwork for understanding how mobile security evolved from GSM's challenge and response approach to the mutual authentication introduced in UMTS. If you have not yet subscribed to the channel, please do subscribe. Mobile subscribers are uniquely identified within a network by the IMSI, International Mobile Subscriber Identity. The structure of IMSI consists of Mobile Country Code MCC, which identifies the country, then Mobile Network Code MNC, which specifies the mobile network within that country, and the mobile subscriber identification number MSIN, which uniquely identifies the subscriber within the network. IMSI plays a crucial role in the subscriber authentication process. The mobile devices in 4G mobile system are referred to as user equipments, which is a combination of mobile equipment and the universal subscriber identity module USIM. USIM is a removable smart card that securely stores the subscriber's identity and cryptographic credentials. It contains IMSI, which uniquely identifies the subscriber within the mobile network, secret key, which is used to authenticate the subscriber within the network, ciphering key is used to generate encryption keys to ensure confidentiality, integrity key is used to generate integrity keys for integrity protection. When a user equipment is powered on with USIM, it starts accessing the network by sending attach request with its unique identity, which is IMSI, and the list of supported user equipment capabilities and attach type, along with serving network ID, that is MCC and MNC of the network, to the eNode B, among many others. In a typical network deployment, multiple eNode Bs exist to extend the radio coverage, and together they form the radio access network RAN, more precisely referred to as EUTRON, evolved Universal Terrestrial Radio Access Network in 4G systems. Based on the attach type received in the request, it is further routed to respective network node in the core network. If the attach type is EPS attached, then the request is routed to Mobility Management Equipment MME in the core network. For this discussion, let us consider the attach type is EPS attach and the attach request is routed to the MME. While many nodes exist within the core network, in this video we will concentrate on those network elements that are involved in the subscriber authentication process. Evolved packet code combined with EUTRON forms Evolved Packet System EPS. As soon as MME receives the attach request, it initiates an authentication info request towards home subscriber server HSS / authentication center AUC by including IMSI, serving network ID and network type details in the request. Once HSS AUC receives authentication info request from MME, it generates 128-bit random number generates 48-bit sequence number, identifies 128-bit secret key based on subscriber's identity, identifies 16-bit authentication management field, and 48-bit anonymity keys. As we have seen in 3G mobile system, message authentication function F1 uses random number, secret key, sequence number, and authentication management field, and produces what is called message authentication code MAC, which is used for network authentication. Message authentication function F2 uses random number and secret key to produce what is known as SRES, signed response, which is used to authenticate user equipment. Then authentication token is also calculated using sequence number, anonymity key, authentication management field, and message authentication code, which will be passed onto user equipment to support mutual authentication. A new key called Access Security Management Key KASME is produced by providing ciphering key, integrity key, serving network ID, sequence number, along with anonymity key to key derivation function, which results in KASME, which is used to generate encryption and protection keys. The combination of random number, signed response, authentication token, and access security management entity keys forms the authentication vector in 4G mobile systems. As soon as HSS/AUC generates authentication vectors, either on demand or fetch pre-computed vectors, it will share these details to MME in the authentication info response. Once MME receives the authentication vectors, it initiates authentication request towards user equipment via eNode B and provides random number, authentication token, and key set identifier for KASME. Once user equipment receives the authentication request with random number and authentication token details, it starts computing message authentication code and compares with the one received from the network in authentication token. If both of them are same, then network authentication becomes successful. If not, network authentication is failed. After successful network authentication, user equipment computes signed response using random number received from the network along with the secret key that is available in USIM and responds to MME via eNode B in authentication response message. Once MME receives signed response from user equipment, it starts comparing with the one it has received from HSS/AUC. If both of them are same, then user equipment authentication is successful and continue to with network attach process. In case if there is a deviation observed with signed response, user equipment authentication gets failed and is unable to access the network. In addition to implementing mutual authentication similar to 3G mobile system, 4G adopts generating authentication vectors per serving network to address replay attacks. As we have seen, user equipment leverages authentication token to authenticate the network, while network uses signed response to authenticate the user equipment, which further helps in avoiding user equipment connecting to false or rogue eNode Bs. At the same time, as the authentication vectors are bind to per serving network, this added security mechanism further helps in mitigating replay attacks or impersonation attempts. A cloned authentication vector from one network will not be valid in another network, adding a layer of fraud mitigation. Stay tuned as we continue to dive into subscribers authentication mechanisms, especially in IP multimedia system in our upcoming video, as IMS enables voice services over LTE mobile networks. Thank you for watching. Hope you find this information engaging and useful. Please like and share with others who might benefit from this insightful information. If not yet subscribed, please do subscribe. Thanks.